Here are the solutions to the Now You Do It part of the Math 138 radioactivity activity. The first one has to do with cobalt 57. If the decay constant is 0.00256 and 46 kilograms are present initially, what remains after 92 days? So, we're going to take the decay formula, A equals A naught e to the negative kt. We know what K is. Recognize we want to know how much remains. That means we want to know A. I know the initial amount was 46 kilograms. So I'm going to put all those numbers in. And 92 days. And then we can just estimate that number as 36.3 kilograms. Okay. Next we have this part of the problem. Cobalt 57 has a decay constant of 0.00256. What a surprise. Find the half-life of cobalt 257. Note the time unit will be days. So this constant has embedded in it what the unit is. Okay, so how do I find a half-life? Well, a half-life, I'm again starting with the standard equation. My K is 0.00256. The half-life is how long does it take 1 gram to become half a gram, 1 kilogram to become half a kilogram, or anything of the like. And I'd like to know the time that it takes to do that. That's called the half-life. So I have this equation. I'll convert it to a natural log equation. So I could take the natural log of this side, take the natural log of this side. It cancels with the e to the whatever function, and I get negative 0.00256t. Now, how do I solve for t? I actually divide both sides by this constant right there, so I get natural log of 0.5 divided by negative 0.00256. And we could estimate that at 270.8 days. Okay, so part C changes the problem a little bit. For an initial quantity of 36.36 grams of californium, 12.2 grams remain after 4.18 years. So, same formula to start with. Let's see which pieces we have. I have the initial amount. I have the ending amount. I have the time. And I need to figure out what the constant is. Well, I could divide by the 36.6. Let's divide both terms by that. 12.2 divided by 36.6 is conveniently 1/3. Sometimes it's not so convenient, but it's still solved the same way. Convert to a natural log equation. I'll divide both sides by negative 4.18, so that's the natural log of 1/3 over negative 4.18. We could then estimate that K at 0.2628. Okay, that gives me the general equation. Now it says how much remains after an additional 7 years. So, how much remains after an additional 7 years? That tells me that I have now a question about the amount. When I started with 36.6, my decay constant was 0.2628, and it's 7 more years, so that's 11.18. years. So I should just be able to calculate that. That comes out to 1.94 grams. Okay, last but not least, archaeologists can use the known decay rate of carbon-14 to estimate the age of organic objects. Suppose Illinois Jones has discovered a wooden spear in a cave. If the wood contains 12% of its original amount of carbon-14, approximately how old is the spear? The half-life of carbon-14 is 5,730 years. So, using the half-life, can we come up with an equation? Using our tried and true A equals A naught e to the negative kt? We sure can. That would say that the half-life is how long it takes 1 gram to become half a gram, e to the negative k times 5730. I'm going to take the natural log of both sides, divide both sides by negative 5730. That gives me a number. I'll estimate that number at 0.000121. Okay? Now I have a good model to go after the second half of the problem. Okay? So, let's see. If I have a percentage, what am I going to do with that? Well, let's just say that to start with, I have 100% of the original matter, and then I end with 12%. My constant is 0.000121. I'd like to know the time that's gone by. So, let's try and figure that out. I'll convert it to a log equation. Divide by this constant. And this gives me my estimate in years. That's 17,500 years. Or that's the estimate if we round off to the nearest number of years.